name is Guang, 12 years old. For this lesson, we'll be continuing on with the techniques and applications for definite integration. For this lesson of definite integration, we'll be continuing on with the next method for this example over here, which is it's double integration y dx dy, d being the boundary, so d over here is the overlapping area of x squared plus y squared is smaller or equals to x, and x squared plus y squared is smaller or equals to y. So over here, when we draw out both circles for x squared plus y squared for both of them, so as you can see for this part, this is the equation for this whole circle, while this part x squared plus y squared equals to y is the equation for this whole circle. Well, what about for the others that are labeled over here? Well, as you can see for this part, the y equals to half minus square root 1 over 4 minus x squared appears on both sides over here, right? But just so you know, for this part, there is going to be two parts. One is the positive, which is above, one is negative, being below. So for this, what we're going to have is going to be from this part to this part, okay? Because this part is the negative part, and if it's the positive part, there will be this part to this part. Well, over here, what else do we have? So we also have this. So what is this part for? So for this part, the x equals to y minus y, square root y minus y squared is basically from this part till this part. Well, for this part, what we're going to have now is, what about for the y equals to square root x minus x squared, and x equals to half minus square root 1 over 4 y squared. So this part also appears on these two sides. So apparently for this part, what we have over here is from here to here. Since it is negative, and if it is positive, it will be from here to here. Well, for the y over here is the positive part, so here to here, and if it is negative part, it will be this lower semicircle. Okay, so it's something like each circle will be split into 4 parts, and for each of these x and y, for the positive and for the negative, each will have a semicircle. Okay. Now we can start on with the question. So first of all, for last lesson, what we mainly did was we had this example, and then what we used is that we integrated with respect to y first. So for this lesson, we're going to integrate with respect to x first, so you can move the y in front. But what are its boundaries? So for the boundaries for x, you can obviously tell that since the x is from left to right, so what we're going to have here is going to be from this part to this part, which is basically this part to over here. Supposedly it's this part, but this is for the y. So over here, as you can tell, is going to be this part, okay, which is over here. I mean these are the same part, so it's this part, it's over here, this part. Okay, sorry. So now that we have gotten our boundary for x, which is from, so now that we have gotten our boundary from x, which is from this part to this part over here, we'll also have to find the boundary for y. So for the boundary for y, we have these two equations, right? X squared plus y squared equals to x, and x squared plus y squared equals to y. Well, for this part, what we are going to have here is, so if we use the process of elimination and all, you can tell that x is equals to y. So what are we going to do here? Since we need to find the boundary for y, we're going to substitute the x as the y, and we're going to use this equation below. So it becomes y squared plus y squared is equals to y. Thus 2y squared is equals to y, and 2y squared minus y will be equals to 0. Well, for this part, what is 2y squared minus y? Well, you can take out 1y and you'll be y times 2y minus 1 equals to 0. So now that we have gotten this part, so we'll be able to get the points of interceptions, both of them. So the first point of interception is when this part is 0 and this part is not. So when this part is 0, y is basically 0. But if this part is 0 and this part is not, that means 2y will be equals to 1, thus y will be equals to 1. So over here we either have y equals to 0, 1 over 2. So this part divide. Or y equals to half. Okay. So it will be from 0 to half. That's our range for y. So now we can integrate for dx already. So when we integrate for dx, it's going to be like this. And now we can substitute the boundary inside, which we will end up with like this. Okay, well, the minus over here, I straight up just minus this part of adding this part because the negative just cancels each other out. Okay. Okay, now moving on to our next step. Over here, we can separate this into 3 different terms. Well, over here, you're going to get okay, so apparently for this part over here, you can use the completing square and you will get so this part what you are going to have here is going to be a negative bracket y square minus y plus 1 over 4, and then here, thus over here, this is minus 1 over 4, so here you need to have another 1 over 4 over here. So this part you basically completing square, and then you get this, and then dy. Well, for this part you can immediately integrate it already, which you're going to get 1 over 4 y squared from 0 to half. And then for this part you can put the y inside for it to be able to integrate. Okay, so for this part, what we're going to have here will be like this. Okay. Well, for this part you have a half in front because of the integration. Well, for this you can straight up substitute this part inside already. So when you substitute this part inside, it will become 1 over 4 times 1 over 4, basically half square, minus the 0 part, which will end up with a 0, so nothing's going to happen, so you can ignore it. Then for this part, minus half, well, for this, having this 1 over 4 is basically just a constant added on. So this is basically his square root x dx, x to the power of half, basically. So you're going to have like this, okay? And now that you have gotten for this part, what we are supposed to do now, so over here, supposingly we cannot solve for this part, right? Well, so we are going to don't worry, it's only applying to the first term, the second and the last term would just, you straight away just sub it in. So you're going to let y minus half be equals to, so what is y minus half going to be equals to? So you want to make it able to take out the 1/4 out, right? So here you can have another half, but half what? So both of these are positive, you want the 1 to 1 and all. So over here we are going to have half sine theta. So y minus half is equals to half sine theta. So what is dy equals to? So dy over here, why I can straight up say that is because when I differentiate, so dy is basically the differentiation for both of these terms. So for this part, what you need, so when you differentiate this term, the minus half would just become a 0. So that's why I can just straight up put dy. Well, for this part, the half will be in front. So sine differentiation is cosine d theta. Then for this part, what else are we going to have here? So what is theta's boundary? And in order to know that, we will also know theta, which, so apparently sine theta is equals to 2y minus 1. So theta will be equals to inverse sine. So over here you just take a clue that I'm going to erase it. Okay. So for this part, what you're going to have is inverse sine 2y minus 1. Then after that, the boundary for theta will be equals to. So if y is equals to 0, what's going to get here is sine negative, inverse sine negative 1. So inverse sine 1 is basically pi over 2, and inverse sine negative 1 is basically and if you substitute half inside, what you're going to get is 2. So over here, so for this part, when you substitute half inside, you times 2, you're going to get 1. 1 minus 1 is 0. So you're going to get inverse sine 0, which is a 0. Okay. Now that we have gotten this let's just, before we substitute it inside, what we're going to do over here is, so for the first term, it will still stay the same until we actually substitute it. Okay, so for this part, what you're going to have is a 1 over 16, obviously. Well, for this part, the 2 over here and the 2 over here is going to simplify, and you're going to get 1 over 3 times, well, what you're going to times here, so when you put half in here, you're going to get a 1/4, which is going to end up with a 0, so you can ignore it. Then after that, you minus negative becomes positive, and then when you sub 0 inside, you're going to get a 1 over 4. 1 over 4 is basically 1 over 2 square, right? Basically half square. So to the power of 3 over 2 will become 1 half square, and would be square root, become half, and then cube. You're going to get a half cube, which is 1 over 8. So 1 over 8. You also have this 1 over 3 over here, which you are going to end with 1 over 24. Okay, so what you're going to have here now for this part, you're going to substitute this part inside, and you're going to get so over here what you're going to get here is the y you're going to substitute inside, which you move this part over here, ending up with this, and then square root, basically a half square minus half square sine square theta. And then for this part, you're going to end up with a half cosine d theta. Then you're going to, so these two, if you put together, you're going to tell how that for this part you're going to have one over 48 over here. Okay, so now that you have gotten this part, what you're going to get next, so you can take out a half from this part, and then you can take out this half square from this part, you're going to get a half, and then you can put this half out, you're going to end up with a 1 over 8. And then integrate from 0 to, it is from negative half pi to 0. Okay, so now that we have gotten this part, what we're going to get over here, sine theta plus 1 square root 1 minus sine square theta and cosine theta d theta. So what you can do here is, for this part, you can separate it into two terms, while for this part, so you are going to use the sine square theta plus cosine square theta equals to 1. So what you're going to have here is a cosine square theta, but since the square root is going to be cosine theta, so when we separate this part, we're going to get a sine theta cosine square theta d theta, and then plus 1 over 8 cosine square theta d theta. And what you're going to get from here is, so you can put this part inside, which you're going to end up with a negative. So it'll be equals to negative 1 over 8 to 0. And then over here you're going to get a cosine square theta. And then for this part on the other, So over here for this part, you use the double angle formula and you'll get this. Okay, so this you can once again separate it to two other terms, while the Okay, so for this part you can already integrate it, which you're going to end up with negative 1 over 8 times 1 over 3 cosine cube theta from negative pi over 2 to 0. While for this part over here, but for this part, the half, you can take it out and you're going to get like this. While for this other part, you're going to have 1 over 32, because not only do we have this half over here, we have this cosine 2 theta, so you need a 2 theta over here. And now we can integrate for these two terms and substitute the boundary inside. So when you substitute 0 inside, what you're going to get here is going to be 1. So you're going to have a negative 1 over 24 minus this power cosine pi over 2 is 0, so you ignore it. Well, for this part, what you're going to have is 1 over 16 theta from negative pi over 2 to 0. Then after that, over here you add 1 over 32 sine 2 theta from negative pi over 2 to 0. And then after that you minus 1 over 48. Now that you have gotten this part, you're going to get, so as you can see here, negative 1 over 48 and the 1 over 24 is basically the negative 3 over 48, which ends up with, wait, give me one sec. Oh, whoops. So what you're going to end up here is when you add these two together, it becomes 3 over 3 over 48, which is going to end up with 1 over 16. So negative 1 over 16, you substitute 0 inside, you're going to get 0, so ignore it. Then when you substitute negative pi over 2 inside, the negative is going to cancel out with the negative from the boundaries. So here you're going to end up with the plus pi over 32, and you're going to have one last part over here. So sine 0 is basically 0 sine negative pi over 2 times 2 is sine negative pi, which is also a 0. So our answer is basically 1 over 16 pi over 2 minus 1. And that's it. Okay. So over here, what we have for this part, so for this lesson, mainly we just integrated it with respect to x first, then after that have we used computing square for this part and got here. And once we get to here, we used the trigonometric substitution as we let for this part. Then for this part, what we used was the sine square theta plus cosine square theta is equals to 1, causing us to get cosine theta to times with this. And then for this part, after we separated it to two terms, the cosine square theta how we use the double angle formula to get the 1 plus cosine 2 theta over 2. And then for this part, what you get over here you separated it, we separated to 2 terms and boom, we get the answer. But for these other 2 parts, it's just basic integration, so you can get it. So just a quick look. So that'll be all for this lesson. Last but not least, thank you for your watching.